So this is the multiple choice review from Unit 1. And we start out with the comparative bar chart shown here is potentially misleading because, we're comparing the position of male and female in accounting, administration, and finance. And then we look at the relative frequency, which is the percents of how often they occur. And the problem is, it looks like there's a huge discrepancy here. It looks like there's a big discrepancy here. The problem is the vertical axis does not start at 0. Okay. A lot of people think the frequency, not relative frequency, should have been showed for the vertical axis. This is the percent of each person. The 3 female bars should have paired next to each other. That's a definite no. The vertical axis should be 5s instead of 10s. Oh, it has 5s instead of 10s. I don't think that matters anything. The 2 separate bar charts, no, we're doing a comparison. And it doesn't start at 0. It should have somehow given us an indication of how that worked. This is not a consistent number. If we're going to go by 5s, then we should have started at 0 and worked up from there. So the answer on the first one is B. The answer on number 1 is B. Okay, for number 2, again, we have a double bar chart. It says Time Magazine carried out a national poll, 501 13-year-olds. One question asked what age they thought would be appropriate for dating, and another question asked at what age their parents thought it was appropriate for them to begin dating. And so they do, again, comparative bar charts that starts at 0. And so based on this graph, which of the following statements is correct? The first one says the proportion of parents is higher in the 16, 17, 18, and older, and the decline to answer categories than the proportion of 13-year-olds. In other words, the proportion of parents are the white bar, 13-year-olds are the gray one, is higher for the 16, 17, 18 and older, and decline to answer. And there's my answer. I don't need to go any farther. The others, I don't care what you read and what you read through it. This is the one. The proportion of parents is higher in the 16 to 17-year-olds, 18 and older, and the decline to answer than the proportion of 13-year-olds. So the answer on number 2 is A. Okay, number 3, I'm going to turn this sideways. No, I'm going to leave it just like it is. It says the stem and leaf plot. I'll pull my answers down here beneath it. The stem and leaf plot, the stem and leaf display shows the service time in seconds for a sample of 25 customers at Frank's Hot Dogs. So our leaf unit is 1. Okay, our leaf unit is 1.0. So this answer then, the sample time is going to be, for number 3, is 80 seconds. That's the smallest amount of time. So the answer to number 3, where the leaf unit, these are the leaves, these are the stem and leaf, is 80. That's 80 seconds, 81, 82, 83, so forth and so on. Okay? So the answer to number 3 is A. I hope you're keeping tally of your answers. Number 4, excuse me. The lengths of 142 roller coasters are summarized in the following histogram. And so it asks, what is the proportion of roller coasters with lengths less than 2,500 feet? Okay, so looking at our graph, there's 2,500 feet right there. You may not be able to see it here, but I can try to zoom in just a little bit, but I don't think it's going to help any. That's 2,500. Less than that means from here to 0. So there's 14 and 4 make 18, and 15 make 33, and 1 makes 34, and this makes 38. So we have 38 out of 142 roller coasters. So that's 38 over 142. So grabbing my handy dandy calculator here and clearing out my workshop stuff, 38 divided by 142 is 0.2676, and they rounded it to C, 0.268. Question 5. It asks, which of the following stem and leaf plots correspond to the data distribution that is negatively or skewed to the left? So we turn it this way because our numbers go left to right. Here's 10 to 17. Those numbers are getting here. That is skewed to the right. That is approximately symmetrical, so my answer is 3. And that answer then is C, 3 only. That is skewed to the left. Number lines go left to right, smallest to largest, so that answer is C, number 3 only. Okay, number 6, a roughly unimodal, roughly symmetric histogram. A histogram below, which the following best describes the typical resting heart rate in this sample. The typical, in other words, the mode, the median, the center, and it's about 65. So it's the center of our graph. It's got the highest, number there. It wouldn't be 75. 75 is too far over. You could count the tops or come and do a rough estimation, but 65 answers C, answers that one best. Okay, number 7 says the frequency distribution shown summarizes data on the percentage of college students enrolled in U.S. public institutions for the 50 U.S. states. And so this is the frequency, how often they occur, right? This is how often they occur of all of these numbers here out of 50. And so what is the relative frequency? In other words, what's the percent? Relative frequency means percent. What is the relative frequency for the 50 to 60 interval? 50 to 60 is 5. Out of 50 is 10%. Relative frequency means percent. We've talked about that. You probably don't remember that, but that's part of this class. Relative frequency means what's the percent. Okay, relative. Frequency distribution is how often it occurs. The relative frequency is the percent. So that answer for number 7 is B. Okay, number 8. Asking that question again. If a frequency distribution is based on intervals of unequal widths, the vertical axis used to construct the corresponding histogram must use which of the following? And that, excuse me, okay, and that answer is C, a density scale, which we hadn't talked about, so I'm giving everybody credit for number 8, whether you got it right or wrong, but that answer is going to be a density scale, okay, because that tells us what proportion of the graph is being used. Number 9 is a repeat of number 7. It asks, what's the cumulative relative frequency for 50 to 60? Cumulative relative frequency means of 50. Cumulative means adding all together. So there's 1 here, there's 5 there. 1 plus 5 makes 6 out of 50. So that's 6 over 50, which most of you know is 12% or 0.12. So the answer to number 9 is C. Number 10. The cumulative relative frequency plot shown was constructed using data on the percentage of college students enrolled at they love this topic. Which of the following is closest to the approximate proportion of states that have fewer than 60% of college students enrolled in public institutions? Okay, the probability they have fewer. Okay, so the following is the approximate proportion of states that have fewer than 60, the closest to the proportion. So this is the cumulative frequency. Here's 60. 60 is a little bit short of 2, but we're wanting, excuse me. So that answer is going to be, here's 60, and this is the closest number. That's 20. It's almost 20%. It's a cumulative relative frequency. Okay, and I want you to know all the states fewer than 60. 60 is really close to 20%. And that's 20% is my closest answer. It looks like 60 would probably be about 18 or 19%. We can't really tell from that, but that's what that would be. Okay, so answer number 10 is B. Number 11, scatter plots. When's the last time you discussed a scatter plot? This was just a question thrown in there. I probably shouldn't have, but I think most of us understood it. Okay, which one shows there's not a relationship? Here, there's a definite negative relationship as those are decreasing. Here, we can almost see a positive flow of these numbers from bottom left to upper right. Here, we can see the negative flow this way. This one, there's no flow. No flow. That answer is 1 only. Okay, that's the only one that doesn't. There's no relationship at all. And so that answer is A, one only for number 11. I know some of you are getting frustrated. Number 12, which of the following best describe the time series plot below? Well, it goes down and it goes up. 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 There is no apparent trend. There's no trend to that. It goes down and it goes up. Okay, down here. So we have each bird in this sample of size 36, the species data. So we have species C that we're looking for, approximately how many birds in the species sample were species C. So if we look at this, this is about 1/3 of our graph. That's about 1/3 of our graph. So we find about 1/3 of 36, and that answer is 12. That looks to be 33 1/3%. It's definitely, this is less than half. This looks to be about a quarter, maybe less. Okay, that guesstimation would be 12. 12 makes the most sense there. 8 doesn't. 20 is definitely too many. 12 makes most sense in that question. Okay, number 14. For which of the following variables would it be appropriate to construct a histogram? Okay, so categorical, we've talked that. Quantitative, we've discussed that. Which one do we use a histogram for? That's quantitative. So color of hair, categorical, quantitative. That's categorical. Brand of stereo, it's categorical. Species of trees, categorical. Gender of an individual, it's categorical. Length of a phone call is quantitative. That's a histogram. That's E. And then last but not least, which of the following variables would have a distribution that is negatively or to the left skewed? Skewed to the left. In other words, if we drew a graph of it, it would look something like this. Most of the data to the right. Okay. And the answer to that is C, scores on an easy test. Most people would score up here 80 and above. It'd be very few people scoring down there on that end. So that scores on an easy test. Scores on a hard test may be roughly symmetric or skewed to the right. Most of them are low grades, bad grades. Okay, number of textbooks in a backpack. We don't even do textbooks anymore. Weights of strawberries. Weights, I've told you, would be roughly symmetric. Okay, so that answer is C. Okay, so if you have questions, you can ask me, but I'm about to post this, and I hope you have a good evening.